In Jesus' name I pray. Amen.
Thank you, Faith.
Amen.
So, Mr. Chakoni, I think you're going to take us through the hydrometer. We left off from purity, density and purity. That is where we stopped. So I think you can take it from there.
Okay, thank you, Madam Javi. Good morning, dear students.
Good morning to you.
The screen what?
No, it's I wanted to ask whether you need me
Yes,
to
Madam Javi,
share
you're
the
asking
notes.
what?
Whether you need me to share the notes.
The notes. Yeah, you can have
On
them
the
in the
screen.
background, but at the moment, I wanted us to.
Yeah.
I'll ask you at that point to do it.
Okay.
Okay. Dear students, since the beginning of our Zoom lessons, we've been discussing one huge topic called density. This is what we've been dealing with since the start. But perhaps to begin with, I'd like to thank Adeke Faith for giving us that wonderful prayer. Yes. So we want to come to the end of this topic, and we shall finish off with something referred to as relative density. Relative density is our topic for today. The question is, what is relative density? So I know that some of you do some research and have read ahead. So does anybody have any idea what relative density is all about? Has anybody heard about it?
Okay, there is, we have some few hands here. Narule Lukia, may you unmute and submit? Narule Lukia.
Relative density is the ratio of a density of a substance to a given reference material.
The ratio of a density of a substance to
a given reference material.
Okay, thank you very much, Lukia. Yes, maybe let me also ask a question. Has anybody ever escorted their parent to a service station when they have gone to service the car? Anybody who has escorted their parent to service a car at a petrol station or something like that, or a garage?
Charity?
Sure. For me, I have an answer for relative density.
Okay, please, what is it?
Well, according to me, relative density is the ratio of density of a substance to density of water.
Ratio of the density of a substance to the density of water. Thank you very much, Charity. Even the previous answer was okay, but it is better to be a little bit more specific. Instead of saying with reference to a particular liquid, we specifically say with reference to water. So the ratio of the density of a substance to the density of water is what we mean by relative density. Now, yes, I wanted to know anybody, if there is anybody out there who has escorted their parent to a service station, to a petrol station or a garage to have the car serviced, to give me the experience.
There's Chirabo. Yes. Chirabo Eunice.
Okay, tell us.
Yeah, I've escorted my father to the garage, and it took a very long time to fix the car. Just I remember.
Okay.
But not of fixing and exchanging of oil, yeah, but it took a really long time.
Yeah. Thank you, Hope. It took a long time. I wanted to know, okay, they had to exchange oil. That's good. That's one of the things that they normally do. The other thing that they normally do is to check on the quality of the acid in the car battery. The car battery, as you know, is the source of energy, electric energy, that the car uses, lighting system, the music that you play in the car, and so many other accessories. The electricity in the car comes from the car battery, and that car battery, within it, it has a liquid, usually an acid, which we refer to as an electrolyte, and that acid, you know, its quality keeps on deteriorating as the car works with time, or as the battery is used with time. The acid deteriorates, and therefore you need to check the quality of the acid that you have in the car. Otherwise, the car won't be able to start in the morning. Now, one of the things that they normally do is to check the quality of the acid, and to check the quality of the acid, they check the density or the relative density of that acid. And how do they do it? The instrument that they normally use is referred to as the a hydrometer. So I want us to play a video here that will help us understand how we can measure relative density, and then we shall then move on. Mrs. Nakpaj will be able to share the screen on the notes, and then we move ahead. Let's just watch this video very briefly, and then we go ahead. I hope it will have an audio component. Okay, there's that very brief video, and this video shows us somebody measuring the relative density of a liquid. Essentially, this is, like I said, it's a continuation really of what we've been doing. We learned about floating, and we saw that an object will be able to float in a liquid if the density of that object is smaller than the density of the liquid in which it is placed. So this hydrometer is simply a device, as you can see, which has got what we call a loaded bulb. It has that bulging part, a bulb down there, which is bigger than the upper part. And within that bulb, there is something heavy, that dark object. Usually they are lead shots. They are called lead shots, small balls of lead. Lead is a metal, which you learn about in chemistry, and later on as we go ahead. So this makes the lower part to be heavy. And so this instrument will be able to float vertically when you place it in a liquid. Now, if you place it in a liquid, what happens is that it floats, and the level which is at the surface will give you a value for the relative density of that liquid. So in this case here, we can see that the reading is not very visible, but if we move it a little bit ahead, we might be able to see the relative density of this liquid, which the substance, the hydrometer has been placed. There is somewhere where they show the reading. Let me see. Okay, there. So it would imply now that the density of we can see that the eye level of the person is at 980, thereabout, slightly beyond 980. So the relative density, therefore, of the liquid there is 0.98. The relative density does not have units because it's a ratio of similar quantities. It should not have units because the units will have cancelled, and therefore we simply say, okay, they have given us 982 because it is slightly beyond 980. So according to the eye level there, so that means that the density for this liquid is, we'll divide this by 1,000 and we get 0.982. So that's the relative density for that liquid. So basically, like I said, the acid that we use in cars should have a relative density of about 1.2 thereabout. And once you go to a service station, they insert that instrument in the acid, and for them, what they do, they simplify it. They put color bands. There is green, there is red, there is orange. If it floats in red, it means the acid is bad. It's got to be replaced. If it's in orange, it's about to get spoiled. And if it's in green, then the acid is still good. So they may not have figures, but they may have color bands so that they make life easy. But basically, it's an instrument for measuring the relative density of a liquid. And this is something very useful, because we've got to do it. All of you know that you use cars, your parents use cars for moving, and you don't want to be inconvenienced in the morning because the battery is not doing well. So that is that. What else do we want to say? This instrument, the hydrometer, can also be used in measuring the quality or determining the quality of milk. Those of you come from those areas where there is a lot of cattle, there's a lot of milking of cows. You know that sometimes, okay, you may not have seen this, but if you take your milk to a place where they sell milk from, you may want to check the quality of the milk, if you've put water in it or not. And again, the hydrometer plays a vital role there. Only that in this case, it has a different name. They call it a lactometer. You may have heard about that. Okay, so I want to hand over back to Madam Nampaji to take us through the notes, and then we see any other thing that are left, and then we wind up this topic.
There are
Madam
some.
Nampaji, I think over to you. Let me unshare this.
Javi,
Yes, please.
are you using Mr. Sanjobe or yours?
Mine.
Okay, let me mute Mr. Sanjobe because there's a feedback. Should we let in some questions? There are some 3 students. Yes,
questions.
Okay, Eunice, unmute and submit.
Excuse me, teacher. On the previous picture, they showed us like someone reading the
Yes.
the liquid. How do you read? Which position must you be in order to read it? That's why I'm confused. Like how do you? Yes, how do you read it?
Mr.
Where must
Chakonya,
you
maybe you can
focus?
share that part again.
Your eye level. You read the eye level.
Yes.
Yes, Madam Nampaji.
I was saying probably share that part again.
Okay. All right. Let me reshare that.
And actually, the wording before that picture explains how the reading is taken.
Yes. So it's supposed to be at the eye level.
The wordings before that picture are there. Can you pause there?
Yes, I have.
Yes, so we take a reading corresponding to the plane of intersection of the horizontal liquid surface at the flat part, and not the point the liquid touches the hydrometer. So maybe now you move on and we see that flat line.
Okay. Okay. So I don't know what's the question, but you heard that we do not read the point where the liquid seems to touch the hydrometer, but rather at the intersection, because there is what we call a meniscus. This point here is called a meniscus. Okay, there is that curvature there. That curvature, we don't take that, but rather we look at the surface, the horizontal line. That horizontal line seems to be corresponding with this line here, this mark, which is beyond 980. So the reading would not be 980, but rather 982. Of course, you need to know the scale that is being used here. We can see there are 5 divisions here, 1, 2, 3, 4, 5, which means each division is 2 units. So that means that the reading is 982. because the liquid surface, the flat surface there, corresponds to that mark there, which is 982. We would not take this because there is that curvature there, which we call a meniscus, and that curvature there at the intersection, we'll explain where that comes from much later. But yes, we'll have to take the horizontal line there. I hope that answers her question. Madam Nampaja, can I unshare this?
Yes, I think you can unshare. I hope
Thank
she has
you.
understood. Let's take other questions.
Okay, I can, let's have Nasolo Betho. Nasolo. Okay, let's try Yvonne. Yvonne.
Excuse me, teacher. You said somewhere there behind you had said that to get the relative density or something, like you get 980 to divide by 1000. Is there a reason why we are dividing it by 1000?
Chajavila, are you answering that?
Yes, I'm here. I thought Mr. Chakonya was going to answer, but Yvonne, we said that relative density is when we compare the density of other substances to that of water. And why we are dividing with 1000, the density of water in kilograms per meter cubed is 1000. The density of water in grams per centimeter cubed is 1 gram per centimeter cubed. But if it is converted to kilograms per meter cubed, then it is 1000 kilograms per meter cubed. That is why this one was divided by 1000.
Also, that is summarized in the definition where I said, yes, Chajavila. Hello.
You can supplement, Mr. Sal.
Yes, when you look at, and also when you look at the definition of relative density, the ratio of the density of a substance to that of water, what Chajavila has explained is summarized in that definition. So we divided by that because of that ratio, that what we divide with or by is the density of water, which is 1 in grams per cubic centimeters, or 1000 in kilograms per meters cubed. Okay, should we let in more people or we?
Okay, we can take. Yes, we can. We have the time.
Okay, Crown.
Yes, teacher, I wanted to know, do you measure like when the hydrometer is put inside the hydrometer? What's that hydrometer jar? Do you measure the bottom? I don't really get it. Are the units, are the numbers on the hydrometer jar or the hydrometer?
The scale, I think Chajava is asking about the scale. The scale is
Hydrometer
on
itself.
the hydrometer.
Yes. That
Then
which
how
you
do
saw
measure
being
it?
put inside the jar.
Yes.
Yes, the instrument the man put into the jar is the one that has a scale at the top. It has something like a neck. So on its neck is where the scale is, and that is what is read off.
But if it's floating, then how does the scale change? I don't really understand it.
It floats at different levels depending on the liquid. So when you place it in water, it will be at 1000, because we know that the density of water is 1000. If it is placed in paraffin, then it will float at a different level. If it is placed in milk, like someone has mentioned.
Okay, teacher.
So it depends on the liquid where it is placed. Yes.
Okay, there's one more question. Charity.
Okay, Mr. Sally.
Yes.
Excuse me,
As we
wasn't
proceed,
able
let's
to
try and we are trying to see whether we can get a hydrometer from the lab here. Before the lesson ends, we show them so that they see clearly how it looks like.
Okay.
Yes,
Excuse
Madam
me, teacher.
Javia.
For me, excuse me, teacher, I wasn't able to watch the video because I had gone off, and I also didn't get the explanation for the hydrometer. So I was just asking if you could explain about the hydrometer. And I also don't get the things about floating, what. Yeah, I was just asking if you could re-explain about the hydrometer.
Such a cool. Oh, she was saying.
Yes, Mr. Sari.
Yes, Mr. Jaconi. Yes,
Yes,
Mr.
I
Jaconi.
wanted to hear what you're saying.
The girl was saying that.
Yes, okay. First of all, I wanted to say, okay. First of all, Mr. Sari.
Yes, Mr. Jaconi.
Are you in the lab as well? Are you in the lab?
No, but I can get there.
Okay, but I hope Madam Napa, you said they are trying to get a hydrometer.
Yes.
It is not in a room behind. If they can get it to help. But
Okay.
yes, to try and help Charity, what we are saying essentially here is that the relative density concept is not anything new from what we did last time. It is a continuation of what you did or what we learned or we've been learning since the beginning. It's about density. First of all, what is relative density? Relative density, by definition, the definition came from your friends, is the ratio of the density of a substance to the density of water. So it's a comparison, something. We are comparing densities of two different substances. The density of an object divided by the density of water. Now, the density of water is always known to be 1,000 kilograms per cubic meter. So we get the density of any other object and we divide by 1,000, and that gives us the relative density. Then the question is, why do we need to know about relative density? Relative density is useful because it helps us to determine a number of things. One of them is, for example, the quality of milk. For those who come from areas which have a lot of cattle and they do a lot of milking of cows, if you take your milk for sale, they may want to know how good your milk is. Or if you yourself go to a place to buy milk, you may want to know the quality of the milk. Now, the instrument that you're going to use to check the quality is called a lactometer, which is simply another hydrometer, and its work is to determine it. It will tell you the quality by measuring the density of that milk compared to water. Now, so when you put this instrument, the hydrometer, has got what we call a loaded bulb, and it has a stem. The bulb is a bulbing part. My colleagues are trying to get the actual thing in the lab because we do have it there. And then it has a stem. The stem is graduated, meaning it has marks on it. And so when you put, because the bulb is loaded, it has, by loaded, what we mean is that it has some heavy things in it. They put their lead, which is a metal, lead shots, small balls made out of lead, and this makes that bulb to be heavy. So when you place this hydrometer into a liquid, it will float vertically. It will float vertically, and the level at which it floats, that surface of the liquid in which you place it, will always be at a point where it gives you the relative density of that liquid. So, like Madam Javia said, Madam Nampaji said, when you place it in water, because the density of water is 1,000 kilograms per cubic meter, it floats in one. If you put it in a liquid which has got a smaller density than that of water, it will float at a value smaller than 1,000 or smaller than 1 usually. And so there we are able to know what the relative density of that liquid is. Mr. Senjove, I don't know whether you've been able to get the hydrometer, the physical one, when it works. You would show our learners when you put it in water. And yes, please. Yes, I can hear you, Madam Nampaji. I can hear you, Madam Nampaji. No, I can't see you. I can't see your video. Could you please put yourself on the video so that I can see? Okay.
Okay, yeah. This is the hydrometer.
Okay,
I have
but
two
yes.
types.
Okay.
Are you still seeing me?
Madam Napa, you are not seeing. Okay, we are okay. We can see you now.
And now this is the bulb.
Yes, you can be seen now. Thank you. Yes.
Yeah, the bulb with the LED shots you're talking about. Then when I put it down, okay, so from afar, this is the bulb. I brought it closer so that you see. That is the bulb.
We can see you. But
Are you seeing me?
I
Mr.
can
Chakonye,
see you,
please
but you are
stop
still,
talking so that they
you are not
see me.
moving.
Let me mute him.
Please stop speaking so that you can view me very well. Okay, so that is the bulb. And then this is the stem. This is the stem. So this is where the reading is. The 980 or the 500, I could bring it closer. So that is the scale that is, we are trying to get a larger container so that we carry out at least the relative density of water from here. They can't see. Okay, that is the scale. Then I also have a different one, a smaller one, but it still has its bulb. And then it also has the stem. The scale is up here. So we've got a container, a large enough container. We're going to measure the relative density of water. So I'm placing my hydrometer. I don't know if I can pull this camera nearer. It is rotating, so we can't clearly see. I don't know whether you're seeing there. The hydrometer is somewhat moving around. But for us who are seeing, the value is 1,000. I'm trying really to show you. It keeps moving. Yeah, I think you can. You can see the 1,000 there. Okay. So this is the hydrometer. This is the bulb with LED shot to give it stability. And this is the graduated scale that is read off. We have, this one is much smaller. You may not be able to read off, but you can see the different types of hydrometers you can have. I don't know whether there are still more questions after this illustration. Let's take maybe a few more questions.
Okay, Katukunda Vanessa. Katukunda Vanessa. Okay, Ashley.
Teacher, is there any specific
liquid to hydrometer, or is it only water?
For us here, we have water that we can experiment on, but definitely the one that was in the video was not water because it came out as 982. This one has been water and it was 1,000, which confirms what we had told you. But we can do for different liquids. Paraffin, Mr. Chakonye has mentioned, they use it to check the purity of milk, to see whether the people who are bringing in milk are bringing in pure milk. So we can get different. Mr. Sanjewa is going to supplement.
Good morning, girls. That instrument, the hydrometer, measures relative density. And its most common uses, like Mr. Chakonye was introducing, it is to measure the relative density of the electrolyte that is placed in a car battery to see whether your battery is still functional or not. Because if the battery is no longer functional, in most cases, what will be happening is that the relative density of that liquid hold an electrolyte that is held in the battery, it has fallen below recommended values. It is no longer the correct value of relative density that is required for your battery to function properly. So that is one use, one type of liquid where the relative density is required is the electrolyte in a car battery. Number two, hydrometers are very commonly used in the milk industry. In the milk industry, they are given a new name, and that name is lactometer. Can you give me lactometer? After I wrote it, I've written these things. But let me first talk about lactometer. Can you give me some of the products of milk, please? Mr. Sally, can you give me some products of milk? Girls, I asked questions. What is milk used for? Mr. Sally, there are so many hands. Mr. Sally.
Ice cream.
Number one is ice cream.
Yogurt.
Yogurt.
Cheese.
Cheese.
Ghee.
Ghee.
Whey.
Okay. Anything other than what she has mentioned?
I had a question.
Yes. Can you first the uses of the milk? Whoever has a question, first listen in. So these different products of milk, all of them have different relative density. So milk is not just thrown away, especially what you know the different products of milk. What you really need to know, the purpose for which you are going to use that milk or to produce a certain product of milk is by determining the relative density of that milk. And that's where the lactometer comes into play, to determine the different relative densities of milk so that milk can be used for that particular product. Now, we can also go to the breweries. Somebody tell me what is in the breweries. I hope you know what a brewery is.
Teacher, I had a question.
Okay, ask.
I'm asking for the parts of a hydrometer. I didn't get them well.
Let's first look at the uses of the hydrometer. I was asking that the hydrometer is a very important instrument in the brewery industry. So I'm asking what is in the breweries? The person whose hand must be raised is telling you what is located in a brewery or what is manufactured in a brewery.
Sophia, come.
They are what?
Wine.
Wine.
Alcohol.
Okay, alcohol. Let's complicate that name. It is a general name. But different wines have different relative densities. Is that okay? So in most cases, you're going to discover that certain wines have better quality compared to others. So to determine the quality of a wine, you need the relative density of that wine, and therefore you use a hydrometer. So a hydrometer has several uses. Those are the different types of liquids in which a hydrometer can be used to determine relative density. I hope we have talked about now the uses. It is not only one liquid that it is water. The hydrometer can be used in several liquids. Is that clear, people? And it is a very powerful instrument in different industries. So those are the few examples of industries where a hydrometer is quite crucial. Okay, now next you want me to talk about the parts of a hydrometer, isn't it? So I'm going to draw to show us a video. We look at the board. Okay. That is the Yeah. Okay, this is our hydrometer. This part which you see here, where the scale is, I hope you see the scale. Where the scale is, that is where the scale is. That part is called the stem. The stem of your hydrometer. Next, it has a wide bulb. This part here is called a bulb. It is given a wide bulb, a wide base, so that it can settle comfortably in the liquid in which you are going to immerse it. A wide bulb gives it stability. And in addition to, at the bottom of the wide bulb, you increase the weight. So you concentrate the weight of this hydrometer at the bottom. And therefore you use what we refer to as lead balls. These small units, you may not see them properly, but they are very tiny balls of lead, and those increase the weight of the hydrometer, and this weight is concentrated at the bottom. The purpose of the wide base and the weighted lead balls increase the stability so that it can stand upright when you insert it in a liquid. It stands upright. It doesn't do that. It doesn't float into the liquid at an angle, but it always stands upright. So I don't know, but we are going to see what you are going to be seeing, and you will see the different labelings of the hydrometer. Is that okay, people? Is that okay? Okay. So the stem, what is on our stem? On our stem, we discover that there is a scale. The wide bulb usually it has a lot of gas to give it stability, and then the lead shows increase the weight, and all these two factors, wide bulb and the weighted lead, increases the stability of the hydrometer so that it settles vertically in a liquid. That is our hydrometer. I'm also share the screen.
Okay, students, we are also going to share a clear picture. So,
yeah, I'm still, I don't know.
Okay, so that is a hydrometer, and those are the parts. If you have any question, you can go on to ask. You can let in some students. Some students can ask.
Please ask if you have. Okay, let me see. I need people who are good. So, Petra?
I was asking about the units. Why is it that they're coming from down, like as they go down, become higher? And they're supposed to come from and they're supposed to be like 1,000, then 900. How comes it's 500 going down? I mean, coming up.
Okay, the units of hydrometer are already 800. Then they increase maybe to 900. Then they go to 1,000. Then they go to maybe 100. Why are they like that? Because we realize that any object, when it is placed in less dense water, if it is placed, listen very carefully, if it is placed in less dense water, it will sink more. So whenever you see the biggest part of the hydrometer is below the water surface, that implies that the liquid you have is less dense. Okay? This would be like a pure wine. Pure wine. Now, when you float it in water, you place the same hydrometer in water, it will sink less. So it will give you a reading of 1,000 because that liquid is dense. So a smaller part of the hydrometer goes below the liquid surface. And that's when you know that that liquid is water. If the liquid is denser than water, the smaller part of the hydrometer will be, and more a bigger part will float be up the liquid. So that is why the readings are arranged in that order. I don't know they get my point. Is that okay?
My connection was a bit unstable. What do the lead shots do in a hydrometer?
These increase the weight of the hydrometer. The weight of the hydrometer is concentrated at its bottom so that it can be able to stand vertically in the liquid in which you immerse it in.
Okay, teacher. That was all.
Keep quiet. Excuse me, teacher. I was asking, when you showed us the hydrometers, there was one that had something like a red liquid in it. I was just asking what liquid that is. And I also wanted to ask for the application of relative density in something about car batteries. I didn't get it. And I also didn't get the point that she explained why the scale is arranged the way it is.
This coloring, please, the coloring you saw has no importance. The red color you saw, it has no significance. Just ignore it. It was just to make it maybe whatever, but the color has no significance. Remember, we have a thin stem to increase accuracy of the readings. We have a wide bulb, and then the weight is concentrated at the bottom. These two factors of a wide base and weight at the bottom increase the stability of the hydrometer when it is placed in the liquid, which will enable it to stand it vertically in the liquid. Those are the purposes of that wide base and the red shot at the bottom. Then the readings, concentrate on the readings. I told you the readings are as follows. We say 800, 900, 1,000, 1. Okay. Now, if this hydrometer sinks, for example, in a less dense liquid like paraffin, it will give you a relative density of 800, meaning that the bigger part of the hydrometer is the hydrometer will sink more in a less dense liquid. Now, if it is placed in water, water has a higher density than paraffin, it will sink less in a dense liquid. So if it is sinking in water, that is the section of the hydrometer that will be found below the water. So this is water, and water has a density of 1,000, meaning it is a dense liquid. So that's why the readings are always arranged largest at the bottom, smallest at the top, to indicate the level at which a hydrometer will sink. We expect the hydrometer to sink more in a less dense liquid and sink less in a denser liquid. Therefore, the readings are arranged from in what we call this, a descending order. Okay, depending, is this ascending? Okay, in ascending, maybe from top to bottom there, it is ascending. Is that okay? Okay, what was the other question? The coloring, I think I answered the coloring.
How it is used in those to milk.
Hey, that density. Now, I told you that in all these industries, I've talked about car batteries, I've talked about milk, I have talked about wines. The values of the relative density determine the quality of that liquid and therefore its use. If the relative density in a battery goes below the recommended value, then you need to replace your liquid by charging or replacing the battery. If milk has a certain relative density, it can use for different purposes. For example, you can take milk as milk liquid, you can take milk in ice cream, you can take milk in ghee, cheese, and so on. All those values, all the relative density of milk keeps changing according to the relative density of the milk, and therefore you use it for a given product. In breweries, different wines have different relative density, and the quality of the wine is determined by its relative density. So that's where the relative density is used in the different industries, and even other industries, by the way, not only these. Thank you. You can read even this from your notes.
Yes, I think we can have more questions. Okay, Narule, Lukia.
Teacher, my question is like when you put the hydrometer in the maybe water, like what you get, the reading you get on the stem is the answer. You don't need any more calculations.
Yes.
Yes.
Thank you.
Okay, we can see someone, Audrey. Audrey. Yes, Audrey. Okay, we can give a chance to Mugabe, Michelle.
I wanted to ask how you get the relative density of a substance. Teacher said something about dividing the density of a substance by 1,000. Is it 1,000 or 100?
Okay, density of water. Do you know the density of water? What's the density of water, by the way? Come, somebody tell me, what's the density of water?
Crown, someone. Okay, Grace Appeal, what is the density of water?
1 gram per
1 gram?
centimeters.
So density of 1 gram per cubic centimeter. What is the other unit? Suppose equivalent to what? What is the value in kilograms per cubic meter?
Okay, someone give us the other value. Mubez, current Priscilla. Mubezi. Okay.
What's the other value? Okay, for time, we are saving time. It is in kilograms per cubic centimeter. Is that okay? Now we have said that relative density
Yes.
Yeah.
of a substance is equal to the density of a substance divided by density of water. Now, suppose you have got a reading of this density as 0.8. That's the relative density. And this side, you have the density of the substance, which we don't know. I'll call it density of substance, density 1. And I'm using the density of water as 1 gram per cubic centimeter. How do I find that density?
Someone give us that answer, Crown. Crown.
I think you multiply.
What will be the answer?
It will be 0.8.
And this side, I multiply by 1 gram per cubic centimeter, and also this side, I multiply by
1 gram per cubic centimeter.
per cubic centimeter. So this will be this.
The answer will be 0.8.
The answer will be 0.8 grams per cubic centimeter.
Centimeter. Teacher, also have a.
Yes.
No, it's
Yes.
okay. My question has been answered.
Your question has been answered.
Yes,
So,
I was asking if you can find the relative density by dividing the density of the substance by the density of water.
okay.
Without the hydrometer.
So if I know the density of water, one of the beautiful things why we use water is because the value with which for pure water is 1 or 1,000. So if you know the relative density of a substance using a hydrometer, you simply multiply that either by 1 or by 1,000 and go the corresponding unit. And that's how we know the density of a substance. Does that make sense?
So that's different from my question.
What is your question?
I'm saying without a hydrometer, can you find the relative density just by dividing the density of the substance by the density of water?
Yes, you can.
If you
What's
know
the formula?
substance, yes.
Okay, give me this is the density of a substance divided by the density of water. Give me the density in your table. Density of gold was given as 19.3. Do you remember that?
Yes.
Now what is the density of water?
1 gram per cubic centimeters.
Gold. So what is the relative density of gold?
19.3.
Is that okay?
Okay, thank you, teacher.
Okay.
Where is it?
Okay, Tendo Tamali. Tendo.
The density of water is 1 gram per cubic centimeter. So is like, I feel like it's going to still, like the relative density is still going to be the density of the substance, right?
Okay. Or correct in your own way, but when you get the density of a substance, you must put there the unit.
Relative density has units.
So I'm writing something on the blackboard. Mr. Sally, show the blackboard, especially this part here. And somebody reads for us as we end up the lesson.
No, the other side. Yeah.
Do they see?
Yes.
Okay. So somebody read for us this statement here.
Yeah.
Can you read it?
Edaline, there is Edaline Dahura.
Shit, I left my camera on.
She's not ready. No, I'm not ready to Gambia.
Density of a substance.
Listen, hear what I say.
It says
Density
of
of a substance is equal to relative density of a substance times the density of water.
Is that okay? Is that okay? So, the moment we get the relative density of a substance, we simply multiply it by the density of water, which is 1 gram per cubic centimeter, then we shall get the density of the substance.
Teacher.
That is one, yes, please.
I wanted to ask, since you're using a hydrometer, can you measure density of opaque objects? I mean opaque liquid, like milk.
Opaque liquids. Opaque liquids like what?
Milk, since you dip the hydrometer.
You can use a hydrometer to measure the relative density of any liquid, whether it is opaque, translucent, or transparent. Because you will see the level where it will stop.
Okay.
The upper lower part will disappear, the upper part will stay up, and it will give you just at the mark, the surface, because where the surface touches, that's the reading that you take. So you can always see the surface of any liquid.
Okay.
Okay, we thought this would be a short lesson. There's an exercise. I don't know how we can handle this exercise. A calculation exercise which you want to post. Okay, we'll do it in the next lesson. We shall try to carry out some calculations as far as density is concerned. We had thought we would do it today, but has not been possible. People, thank you for your participation, and I hope the many questions that you have asked have given you a better understanding of relative density. We want to wind up, but we pray that you can read. I don't know whether Mr. Chako has something to say.
Yes, thank you so much, team over there, for that good work. Yeah, that was very good. I wanted to add that maybe for purposes of emphasis, that as you said, relative density has no units. They have to note that. And I think there is a student who raised something very important there, that the relative density of a substance is in fact equal to the density of that substance in grams per cubic centimeter. That is a very important point to note. Relative density of a substance is equal to the density of that substance in grams per cubic centimeters. And if they want to convert that to density in kilograms per cubic meter, then they just have to multiply by 1,000 using that conversion factor that you've written at the top. So the pointers that they have to take a note of. Then the other thing I wanted to mention was that sometimes as they read different sources of information, they might come across a term, specific gravity. Sometimes some books refer to relative density as specific gravity, so they should take note of that. Finally, I have put, like you told me, requested me, Mr. Senjowe, I have put an exercise there, a self-marking quiz about density, which they can attempt, but I put a deadline that it should be attempted latest Monday, 19th. I don't know whether they will be ready for it because it looks like they needed some more examples on numeric examples on relative density because there are some relative density questions there in. So maybe I may have to readjust the date because if somebody has not been moving ahead and they do a little bit of work on their own, then they might not be able to pull off some of those numbers in there. But otherwise, the exercise, the quiz is already there. 25 questions. Yes, please.
Is it possible to extend the deadline beyond, because I mean Tuesday, because that's when we meet them, that's when we shall look at calculation. Maybe we can just extend the deadline beyond Tuesday.
Okay, I'll already just sit up to Friday next week. Eh?
Okay.
I will adjust it. Thank you.
Okay.
Thank you. That is all from me. Thank you very much, team over there.
Girls, have a nice day ahead. We are letting you go now to prepare for the next lesson.
We still had a question. Then throw them if they weren't.
I'm like, going to school.